Given that 1 plus I is the root of the equation, so you 2w cubed plus aw squared plus bw minus 2 equals 0. Find the values of the real numbers a and b. Alright, so from here, okay, so we can use factor theorem. So if 1 plus I is a root, right, if we sub it in, we sub in the equation, that should give us 0, right? So by factor theorem, okay, so if 1 plus I is a root of the equation, alright, what we need to do, you just sub it inside. You can see 2 1 plus I cubed plus a 1 plus I squared plus b 1 plus I minus 2, it should give me 0, right? So it should fulfill the equation. This is by factor theorem, right? Alright, so what I do is I just further go on, you expand this, so I just leave it as it is, right? And expanding 2, 1 plus I, you're going to 2, negative 2 plus 2I. Okay, I'm going to leave the expansion to you. A of 2I plus b plus bi minus 2 be equals to 0. Alright, and finally we group the real and the imaginary parts together, and all goes well. Okay, I'm going to leave it to try. You're going to get b minus 6 on the left hand side as the real part, and on the imaginary part will be 4 plus 2a plus b bracket I equals to 0 plus 0i. Okay, and if we compare the real parts, right, because it's equal to 0, so 0 means that the real part is 0, the imaginary part is also 0. Okay, so if you compare the real parts, it means that the b minus 6 is also equal to 0, b should be equal to 6. If I compare the imaginary part, 4 plus 2a plus b will be equal to 0. Now since b is equal to 6, that means you have 4 plus 6, 10 plus 2a is equal to 0, and it means that your a is just equals to negative 5. Alright, and with that you have found your a and b. Okay, next, for these values of a and b, right, we want to solve the equation in part 2 without the use of a calculator. So without the use of a calculator, you must really show the approach without using any calculator to help you solve. Alright, since the polynomial, okay, so we know that 1 plus I is a root to the equation, right? 2w cubed plus aw squared plus bw minus 2. So you observe, right, what can you say about all these? The coefficients are real, right? In fact, we have found 2, we have found a and b, so a would just be negative 5. Okay, so let me rewrite the equation. Okay, it's actually, the equation is 2w cubed, a is found, so it's negative 5w squared, b is found, which is 6w minus 2 equals to 0. So this is my equation. 1 plus I is a root. What else can you say? Okay, you can see that all of them are real. So you can use the conjugate root theorem. Alright, so that means, right, since the polynomial equation has real coefficients, 1 plus I and what else? 1 minus I are roots. They are also both roots to the equation because they are the conjugate to each other. Right, because all the coefficients are real, therefore 1 plus I and 1 minus I are both roots. If I compare the constant, okay, so what can I do that? From here, if I know that they are both roots, I can write my equation in this way. Alright, since this one I can see a coefficient of w cubed, I can write something like this 2w minus a, okay, for example. Alright, because this one, remember, this will be the last root, right? So if it's power 3, I have one pair of conjugate roots. The last one should be, is it imaginary or real? Should be real, right? Because roots come in pairs, complex roots come in pairs. The last one should be real. Okay, the next root should be w minus 1 plus I. Okay, this is one root. The next root should be w minus 1 minus I, correct? This will be equals to 2w cubed minus 5w squared plus 6w minus 2. Right, so basically what I'm doing is I'm writing it as a product of its factors. Okay, since I'm assuming that a 1 plus I and 1 minus I are all the roots of the equation, these two are complex, this one is real. So now what remains is we're going to find a. right? And I can actually combine this part, right? This is just a square. I can actually combine this part, right? Oh, so this is the same. Okay, this is the same. So what I do is I expand this. Okay, w minus 1 plus, I can write it as w minus 1 minus I. Okay, same for the right hand side. And you see that I can write this because it's a minus b, a plus b. I can write it as a square minus b square. Minus I square is the same as plus 1. So this will give me w square minus 2w plus 1. Okay, this will on the right hand side be 2w minus a. Again, this is 2w minus a, right? So copying down, equal, this is equal to 2w cubed minus 5w square plus 6w minus 2. Then by comparing the coefficient of the constant, you can see it 2a 1 on the right hand side, right? If you compare the coefficient of the constant, right, 2a will be equals to negative 2. The right hand side, the constant negative 2, right? So with that, negative 2a, sorry, a is equals to 1. Okay, with that we can actually we have actually found the last root, right? So your equation, basically, this is your equation. It's just a 2w minus. Okay, so it should be negative 4a. So apologies, not 2a, but negative 4a equals to negative 2. So a should be equals to half, right? Okay, and with that, you can see that our solution is none other. From this, you can see that our solutions w is equals to 1 plus I, 1 minus I, and half. Okay, half, 1 minus I, 1 minus I, and 1 plus I. Okay, so we have 3 solutions, and that's our solution for this we have solved the equation in part 2.